Hi, Professor Gassimi here. In this first part of Lecture 2, we're going to be discussing some of the properties of language. Just a quick reminder, last week's lecture we covered some information about the course, our syllabus, and the expectations for this course. At the end of last week, you should have completed homework 0, which involved setting up your notebook and your GitLab repository for submitting assignments. And you also should have a basic idea of what's expected from you for the purposes of the project. In today's lecture, we're going to be covering natural language processing fundamentals. This includes topics like words, stop words, regular expressions, text normalization, edit distance, n-grams, all the way through language models and how you do smoothing of those language models. We'll also be talking a little bit about our homework assignment. I'll be stepping you through some tutorial sections of that homework and also highlighting which sections you'll be expected to complete on your own and submit a week from today. So when we speak about language, what are we really talking about? Well, language is just a set of conventions that species use to share mental representations. And by the way, when I say species, I'm not just referring to us, obviously. I'm referring to birds, cats, dogs, wolves, you name it. All of those species have vocalizations of some kind, and they use those to convey information to each other that helps the survival of the species as a whole. So language is not just unique to humans. And interestingly, it's so ubiquitous that we've even been able to perform interactions across species. You might have heard of this example of Alex the parrot, who knew up to 100 words before he passed away. And there's been examples of chimpanzees that have been able to learn human sign language to communicate their wants, needs, and desires. Critically here as well, language doesn't just have to be written in words, a string of characters that together provide some meaning. Language is any convention that we can use to exchange ideas. So mathematics is a language. The Python programming language is, as the name says, a language. And the Mayan pictographic language is also a language because all of these things allow us to exchange ideas across our species. And on that note, it can also be nonverbal. So the way that my body posture is, or the way that even my voice sounds as I'm performing this lecture, is going to convey some meaning to you. If, for example, I spoke like this versus if I spoke like this, you're going to interpret the content of my message very differently. So part of what we use to express our ideas and express meaning is conveyed in not just what we say, but how we say it and how we look as we say it. And I thought that just to get that point across, that language really doesn't have to just involve words. There's an interesting example of a village in Turkey where for communicating over long distance, they use whistles. And I think there's a similar language, albeit unrelated, that exists in the Canary Islands in case you'd like to look into it. So language is a set of conventions that our species uses to share mental representations, and words are specific components of those representations that we're sharing. They allow us to communicate specific physical or experiential phenomena so that we can perform statistical or logical reasoning about potential realities. You may recall from our first example in the lecture, we spoke about a red tree. But when I say the words red tree, there's some idea in your mind's eye about what red is. There's some other idea in your mind's eye about what a tree is, and you can combine those two images together to create a red tree. Now, what's powerful about this is not just that you can do it for a red tree, which you may have seen before, but you can do it for a kind of tree that you've never seen before, a pink tree, purple tree, a rainbow tree, or whatever kind of tree we might be speaking about. But of course, the way that words are represented in your mind is probably not one-to-one. Because when I say tree, there's probably a huge number of words that you've seen that match that very general description. So the way to think about the connection between language and thought is more like a distribution. If I say the word bird, there's actually a set of birds that exist in your mind that you've previously seen. Those birds probably share some properties like they have beaks, they have feathers, they fly, etc. And you cluster all these specific images of birds in your mind's eye into some other kind of abstract mental representation that describes birds. And you can use language to perform manipulations of this distribution or mental representation. One could tell you the word bluebird, and all of a sudden you kind of marginalize out the pieces of that don't matter, and you focus only on the component of the mental representation that describes the bluebirds. Or we could say small bluebirds, and you can squeeze that distribution to an even smaller component that's representative of your previous experience with small bluebirds. And the really powerful thing about language, with respect to its ability to manipulate these mental representations, is we can just add a single word in front of a small blue bird, the word not, and all of a sudden your representation in your mind's eye does all but include that small blue bird. So it's a pretty powerful construct. Now, one of the interesting things about language is that it allows for many-to-one mappings. So you have these things called syntets, which are a set of one or more synonyms that are interchangeable in some contexts without really changing the truth value of what you're speaking about. As an example, I can use the word sing, serenade, and chant. If I mention those three things, there might be soft differences between those in your mind's eye, but they're probably roughly referring to the same thing. In the natural language processing context, you will often hear people speak about something called stop words. Stop words are just symbols that don't really contribute meaning to, or might even distract from, the symbolic reality that we're trying to get across or evaluate. And so they are task dependent in that sense. So for example, let's return back to the birds. If I added the two words like and before not a small bluebird, your mind kind of filters those two words out, as in they provide no additional value to you if your goal is to try to figure out what kind of a bird I might be describing when I say like not a small bluebird. So when you hear people in academic papers speak about stop words, just understand they're speaking about words that don't really help contribute to the task that you're trying to accomplish. And for that reason, stop words can differ depending on the task. Now, when we're having conversations with people, and there's a lot of words that transpire in those conversations, we organically add small breaks, pauses, changes in our inflection or intuition, so that people can understand which ideas are grouped together and which are not. Now, in the context of written language, punctuation serves that purpose. Punctuation are just basically a set of symbols that help clarify the meaning of other symbols. They're putting the pauses and the breaks that happen organically when we're having a conversation with other people. And to kind of highlight what the importance is of punctuation for actually understanding a text, I wanted to read you a passage from William Faulkner's The Sound and the Fury, page 105. And this is actually quoted from his text. I'm going to read it exactly as it's written. My God, this cigar, what would your mother say if she found a blister on her mantle just in time to look here, Quentin, we're about to do something we'll both regret. I liked you. As soon as I saw you, I says he must be. Now, obviously that was probably challenging to understand. Faulkner actually was aware of that, and so his suggestion to people who struggled to read it was that they should just read it multiple times. Now, if you're not planning on becoming a Pulitzer Prize winner anytime soon, you probably would want to use punctuation in your language. So I've actually taken Faulkner's work, and I dare say I've improved it by adding commas, exclamation marks, and other things to help improve the readability of it. So let's go through it once more just to highlight. My God, the cigar. What would your mother say if she found a blister on her mantle? Just in time to. Look here, Quentin. We're about to do something we'll both regret. I like you. Liked you as soon as I saw you. I says he must be. So what you can see there is that just The subtle pauses in the language changed how easily you could interpret it. Why is this important? Why is it worth me bringing this up? Well, because if you're going to be designing artificial intelligence systems, you're going to need to take advantage of the punctuation that exists in text if you want to actually understand the intent of the author. The symbols themselves are usually not enough. Okay, so language is a set of symbols, and language contains other symbols that help clarify the meaning of those symbols. Well, a first order question that we could ask if we were really interested in language is, what's the frequency of those symbols that show up in a language? So if we took the English language, for example, and we wanted to count how frequently words occur in the language, which words would show up as the first most common, second most common, third most common, and so on. Well, that's actually what I'm showing here on the screen right now from a website, wordcount.org. It was written by Jonathan Harris. What it shows is that you can take words and you can sort of rank order them according to how frequently they show up in our language. For example, this says that the word the is the most common word in the English language, followed by the word of, the word and so on and so forth. And what this distribution down here is showing us is how frequently does the word the occur relative to the next word over and the next word over and the next word over and so on and so forth. And what you'll notice about this curve here is that it's following what we sometimes call a power law distribution. That is to say that the frequency of the first most common word, which is the, if that happens X times, the next most common word in the language happens about half as often, third most common word happens about a third as often, and so on and so forth. Now, if language, or at least the English language, let's say, is distributed this way, there's some interesting mathematical properties that we can point to. The first of those is that if you knew the 100 most common words, you should be able to read 35% of the total words in the English language. That's pretty incredible, right? I mean, just 100 words and you could get 35% of every word that was ever written in English. You would be able to understand that. And furthermore, if you knew the top 1% of the most common words, so 868 of them, you should be able to read half of all the words that are ever written in English anywhere. And if you knew just the top 20% of the most common words ever written in English, so 17,000 out of 80,000 or so, you should be able to read 80% of the total words written in English. And there are some estimates that say that it may in fact even be lower than that. Well, this observation that we just pointed out about the distribution of words with respect to their rank and how often they're used in language with respect to their rank was actually first noticed by a gentleman by the name of George Zipf. He was a philologist in 1935 who said, hey, let me take the log of the number of words on the x-axis. Let me plot that by the log of the number of occurrences of that word in a bunch of text that I've collected. And he sort of hand sketched this plot that you see here. Well, because these two are on a log scale, the way that you can interpret this plot is that basically most words are used very rarely, but only a few words are used incredibly often. And this doesn't really just show up in English. George Zipf also, when he experienced this, decided to look at other languages like Latin, and you can see that a similar trend occurs. It occurs in Chinese. It occurs in the syllables within Chinese. It shows up over and over and over again, no matter which language you look at. That is to say that in any language that we will be speaking of, one of the properties is there's a small set of words that are used incredibly often, and there is a large set of words that are used very rarely. That has implications for how you might train a system, let's say, that parses natural language. And of course, when I first encountered this, I thought, geez, like, is language really that deterministic? Well, maybe there's some important differences across language groups in terms of the things that we speak about. But there's been studies that have shown that actually the kinds of things that we like to speak about across languages also tend to be very similar. And the way that they've done that analysis is they basically took all the languages in the world and they tried to kind of cast them to a single language. Let's say we took English, Chinese, Spanish, and all the other languages, and we casted all the words, translated them all to English. And then we came up with a rank for each of the words according to that. And we, according to the rank across all the languages, plotted again the relationship between the frequency and the rank across all the languages. Well, what you end up seeing, which is what the figure on the right-hand side there shows, is that you still get something that looks very similar to Zipf's law. And that implies that across languages, we're also speaking about very similar things. That's important for us to know because if you're going to be performing natural language processing in English, there may be certain things that you could learn that would help you do natural language processing in Spanish or Chinese or Greek. So on the topic of words that show up frequently, up till now, we've only seen words like the and or and in as the common words that exist in our language. Those aren't really interesting though, right? They don't tell us a lot about the kinds of things that we think about as a species. But if you look at the most common nouns, verbs, and adjectives, I feel like it does tell you a lot about the things that we care about as a species, as evidenced by the fact that they're used very frequently in our speech and our writing. So looking at the nouns, for example, you can see we care about people, we care about time, we care about men, women, and children, we care about places, we care about the world, we care about the government, we care about work, facts, problems, numbers, etc. If we turn our attention to verbs, we care about what we have, what we're going to be, what we're going to get, what we know, what we can make, what we can do, and so on. And if we think about the kinds of adjectives or the properties of things that we tend to focus on, we're interested in whether something is the first or it's the last. We're interested if things are good or if they're great. We're interested if things are young or if they're old. We're interested in things that are little or small or long or important and so on. I'll actually highlight here that the three most common words at the time when I looked this up were time, be, and good. I really think that this says something about the greater psychology of us as a species and the kinds of things that we're often thinking about. So language definitely has some interesting properties, statistical properties, but it also has some challenging properties as well. Language is nonlinear, it's non-stationary, it's noisy, it's high-dimensional. I think the best way to understand what I mean by that is to step through a couple of examples. When we spoke earlier about serenading, chanting, and singing, it was clear that there was a many-to-one relationship between those words and a concept in your mind's eye. But one of the things that can make language very tricky is that single terms can have more than one meaning depending on their context. For example, if I say the word kid, kid could actually refer to a young human, or it could refer to a strapping young goat. And to make matters more complicated, even if I can figure out from the context what a kid is referring to, there are similar symbols in sentences that can have different meanings. So for example, in the sentence I'm showing there, my nice niece is visiting niece. Notice that the word nice is spelled the same as the word niece, but the word niece, referring to my niece, is pronounced similarly to the word Nice, referring to the city in France. Now you can just read that sentence and all of those complexities and contradictions in the language just get ironed out. But if you wanted to build a system that uses rules or statistics to figure those things out, it would definitely introduce some complexities. To make matters even more complicated, these symbols and the way that we parse sentences don't just depend on context within the language itself. They depend on a temporal context. The word nice, for example, a couple hundred years ago, actually effectively meant not nice. And so if we were reading this sentence a couple hundred years ago, we would interpret it very differently than we interpret it today. And it's not just that time has an impact on how we interpret things, but even your location can impact how you would parse a sentence. If I changed it to say that my nice niece is visiting Nice for a football match, and I was here in the United States, well, I might interpret that football is referring to an American football match. But if I came from the UK, or maybe this sentence was said in the UK, I might interpret that we're speaking about soccer or English football. So anytime there's a confluence of interesting problems, hard problems, and high impact, you have a great grounds for research opportunities. And natural language processing is really one of those domains. There's a lot of problems that exist in NLP due to all the complexities we discussed earlier that are far from being solved. Consider just the very simple problem of searching for red birds that are not cardinals. If we go to Google Images and we type that string into the search query box, you can see that roughly half of the birds that get returned are in fact still cardinals. And if we think about the evolution of chatbots over the last 60 years or so, a lot of what chatbots struggled in the 60s are some of the same issues that chatbots struggle with today. On the left-hand side there, I'm showing you the ELIZA system, which is a mock psychotherapist that was built at MIT. And it was actually pretty straightforward. What the ELIZA system would do is it would try to take basically any text that you provided it and try to kind of turn that text around back at you as a question or a vague enough statement that you could respond and carry on the conversation with it. The ELIZA system was, again, implemented in 1966, and it used this strategy of posing questions when it didn't know how to respond. And if you look at a chatbot now from 2020, Google's Mina, you can see that there's a similar way that Google's Mina handles that situation that, again, reflects opportunities for growth and improvement. So consider the following text directly from Google's repository. A human being says, "Hi," Mina says, "Hi, how's it going?" The human says, "Doing okay, feeling a little bit under the weather." To which Mina responds, "I hope you feel better soon." Human then responds, referring back to the weather comment, "Thanks, the weather is getting worse." Mina says, "Oh no, I'm sorry, I hope it gets better for you soon." The human says, "Won't get better anytime soon, we have to wait until spring." Mina says, "Sorry to hear that." Human responds, "Yeah, I'm really feeling under the weather." In which Mina responds, "Well, that's no good." Now, what do you notice about this interaction between Mina and the human? Mina's not really saying anything specific. It's very kind of general. It's vague. She does not necessarily have an in-depth understanding of the verbal sleight of hand that the human being is doing when they say, "I'm feeling under the weather," and then talk about the weather improving in spring. Those connections, that linguistic subtlety, is lost on the chatbot. So have they improved over the last 60 years? Absolutely. Do they have some of the same deficiencies that they've had since the 60s? Again, absolutely. Now, I want to also highlight that one area where I think there's lots of room for exciting research potential is in the domain of texts that are not corpora. So corpora, by the way, is what we refer to as structured sets of text. So for example, if I have a handwritten note sitting on my desk, that's not a corpora yet. We have to take it, we have to scan it, run an OCR system on it, and get it into a format where your computer can start to manipulate it before it's a corpora that you can deal with. And although we won't be talking about it very much in this course, the field of optical character recognition and things like that, I think there's a huge amount of text that's actually locked away from the natural language processing community that is the pre-digital era, if you will, and even a lot of things that are in the post-digital era. The example I'm showing there on the right-hand side is spreadsheet images from a clinical setting. And what you can see is that there's kind of let me say, interesting metadata, which is the structure of the document that you'd have to account for if you wanted to read that, that doesn't just have to do with the sequences of the words, which most of natural language processing is built around. I bring all these to your attention because, as you know, at some point in this class, you're going to be doing a project. And some familiarity with where some of the deficiencies are in natural language processing might give you some ideas about where you want your project to head.